Good afternoon and welcome to today's HydroCAD webinar. Today's session we are going to be talking about the Pavedrain product, which is a very unique product that provides a permeable paving solution as well as a stormwater storage potential. And joining us during today's session will be Doug Buck, who is the president of Pavedrain, and Dan Bishop, who is with Ernest Mayer, also known as MCO Block. My name is Peter Smart. I'm the developer of HydroCAD, and I'll be organizing this afternoon's session and doing the HydroCAD presentation. We're roughly going to do three separate pieces in this session. We're going to do an introduction talking about the Pavedrain product and just how it's used and what it's most appropriate for. And both Doug and Dan will be talking a little bit during that session, and we'll deal with any questions you have about the basic product. I'm also going to be doing a presentation about modeling Pavedrain systems in HydroCAD, and we're going to talk about laying out Pavedrain systems, about the HydroCAD Chamber capability and how that relates to a paving product, and then how we would model the Pavedrain system, both its storage capabilities, how we would look at runoff and infiltration issues, and also how we can combine Pavedrain system with other storage elements such as underground storage chambers. This is a new capability we have in HydroCAD starting in version 10, modeling the Pavedrain, and we'll be talking a little bit about the version 10 update. To get started here, I'm actually going to turn this around at the moment, and let's talk a little bit about the HydroCAD modeling first. Before we do that, I'd just like to get an idea of the background of the folks that are with us today. And I have a couple of polls I want to put up here. First of all, just to get an idea, how many of you have used Pavedrain products before? Are you familiar with the system? And this will just help us to gauge the amount of detail we provide. So it's looking like about a third of you have used Pavedrain systems, so we will give you a little bit of background to make sure we provide that information. And then there's our results on that poll, for example. And then the second question I had is I wanted to get some profile on how many of you are familiar with HydroCAD, how many have used HydroCAD before. Okay, so we seem to be pretty well split, actually. Half of you are HydroCAD users, half of you aren't. All right, so we'll make sure we provide a balanced presentation there. And so let's start by having a look at HydroCAD. So if we launch HydroCAD in order to see what we can do with Pavedrain, and actually, I see that Dan Bishop, in addition to Dan, Doug is also with us. So let's do the original plan here, which is to talk a little bit about the Pavedrain product first and give you that background before we launch into the HydroCAD side. So Doug, are you with us? Can you?
I am.
Excellent. Good afternoon.
Good afternoon.
So do you want to tell us a little bit about Pavedrain and how it came about and what its goals are? And I can switch the screen over so that we can have a look at any materials you have, or we can just leave the Pavedrain website up while we do this, whatever you prefer.
Why don't you just go to the, excuse me, let's just put up the Pavedrain website.
Okay, there we go. So go ahead, please.
All right, my name is Doug Buck. I'm the inventor of the Pavedrain system, and I was in the articulating concrete block world on the Armor Flex side of the business for almost about 15 years. And got out of that about 3-4 years ago, and came up with the Pavedrain system as an answer to all the permeable work and requests that we had out there, and looking at municipalities, DNRs as an alternative to traditional paving and other permeable type surfaces. So I just combined everything that I already kind of knew in the articulating concrete block world and came up with Pavedrain and incorporated an arch into it, and have set up manufacturing distribution throughout the country and growing in the world, and have really had some almost amazing success for a product that's only, we've R&D'd it for about 3 years, almost 4 years, and I've had a tremendous amount of success and response in the marketplace in the last, it's called 6-8 months. We have projects on the books and on the drawing boards from coast to coast, and makes it a very viable product in local economies. The engineering community, the acceptance of permeable surfaces has been lukewarm, to describe it. Once we launched Pavedrain into the consulting engineering world, the response was just tremendous. They realized the size, the heftiness, the bulk of the product, and what it can do. And what they asked for in during sales calls, meetings, presentations was HydroCAD. So my licensee on the East Coast, Ernest Meyer, Inc., one of their vice presidents, Dan Bishop, and I got together and said, let's get going with HydroCAD. And Dan kind of spearheaded it with Peter, and here we are today.
Okay, well, excellent. That's really good to have that background. As you've suggested, I know that there's a lot of hesitance out there to using permeable products, whether it be permeable concrete surfaces or asphalt or a paver, as you have. My personal view on this is that we certainly need to be introducing more pervious surfaces rather than just using impervious paving as a universal solution. And certainly there are different issues that arise with the maintenance and performance of those pervious surfaces. But of course, we have all of those similar issues with an impermeable surface. We're already dealing with the runoff and the contaminants and the cleaning and the maintenance issues. So it's different. My personal hope is that long term we'll adapt and find that overall it's a better solution. But I hear you as far as the resistance that you run into. We certainly hear this from engineers just as far as using products like a permeable concrete or asphalt surface. Good. Well, is there anything else at the moment? Otherwise, I will go ahead and talk a bit more about the modeling in HydroCAD.
Go ahead, Peter.
All right. Very good. Let me do that. The way we deal with Pavedrain product in HydroCAD is that our primary goal is to model the storage capability of each block. And in doing that, we actually have the Pavedrain set up as a chamber definition. So it's being treated similarly to an underground storage product. Now, naturally, the Pavedrain is a surface paver, but it still has an internal storage arch, and it also has storage in the gaps between the blocks. So in order to model these capabilities, we have a definition set up in the HydroCAD Chamber library. So if you open the Chamber report and scroll down and expand the Pavedrain option, you will see a cross-section that's displayed for a Pavedrain block. Just a little bit of explanation of what we're seeing here on the screen. We have the outer rectangular shape of the block here, fairly obvious. And then this dashed line is showing us the internal storage within the arch in each block. There is also in this report a little chimney here, which I just want to explain. This is essentially showing the space in the storage in the gap between the blocks, but at present at least the chamber report graphically shows that storage in the center. So we basically have that edge storage moved into the middle. So numerically it's a very precise representation of the stage storage relationship of the block, but the graphical view is just a little bit odd in that we have the center chimney. When you look at other storage products, you're able to compare those in the library. So we can open up any other chamber definition, and this is what you would traditionally have used the chamber library for in HydroCAD. It's to look at various underground chamber storage products. But they all have unique stage storage characteristics, which is why we're modeling the Pavedrain as a chamber definition within HydroCAD. And we'll talk a little bit later about how you can actually combine these storage products in order to create more complex, sophisticated applications. So the chamber library is very handy because you can view any of the chamber products that we have in here. You can compare their cross-sections. One thing that's often interesting to do is to look at pipe products, and you can compare pipes and see how their cross-sections compare to different chamber products that you might be using as an alternative. Now, in the actual modeling of a Pavedrain installation or any chamber installation in HydroCAD, what we need to do first is we need to open a project. So we can go to Project Open, or we can just click on the blank screen, and we would simply type in a name for the project that we want to create and say, yes, we want to create that. And we now have a blank screen for our new HydroCAD project. And what we want to do is define the storage element for the Pavedrain block. And we do this by creating a pond. So coming over to the palette, we drag a pond node into our diagram. And this is a new pond. It has no existing description. So if we double-click that node, it opens up the editing screen. So we can enter specific information for the pond. What we want to do here is select Detention Pond. The detention pond option indicates that we're going to be defining storage for this particular node. And so when we select that, we get a storage tab which has appeared at the top of the window. We also have additional tabs for outlet devices, which we may not be using at all. Also tailwater capabilities. Again, we don't have to use this if it doesn't apply. And then we have an advanced tab with other settings, and finally a tab to put in notes so we can explain the details of what we're actually modeling with this particular pond. It makes your HydroCAD reports more self-explanatory so that reviewers will know what you've done without having to come back to you with too many questions. So what we're going to be focusing on is primarily the storage tab. When we pick the storage tab, we get a table in which we can enter multiple storage definitions. Each pond we model in HydroCAD can have several different elements that make up the storage. It might just be one open excavated pool, but it could also be underground chambers plus storage contributed by pipes and perhaps Pavedrain system above that on the surface of the ground. And these would be entered using multiple lines within the storage tab. So to start, we can just double-click any blank line in this table, or we can click the Edit Storage button. And this brings us up to a screen that lets us select the particular type of storage that we want to define. The left side of this screen shows the basic storage options. And one of these is prefabricated chambers. And we could use this in order to model the Pavedrain on its own. This will set up the basic storage information for the block. But in most cases when you're modeling chambers, or a block in this case, it's preferable to use the Chamber Wizard. The Chamber Wizard does a much more powerful process for us. It models not only the chamber or block, but it also models the stone surround or bed in the case of the Pavedrain. And it sizes that automatically based on the size of the chamber or block installation. So if we select Chamber Wizard and click OK, this launches the Chamber Wizard screen. And it's really very easy to use. It's a big screen, but very straightforward. And the primary thing we want to do is come to the upper left-hand corner here, and we want to come down and select the specific chamber product that we want to use for this installation. So I've picked the Pavedrain. And in this view in the center, we are seeing here an end view of the system. So we're actually looking at the end of one block here. The arch isn't shown in this particular view, but it's there in terms of the storage. So we have an end view showing the block sitting on top of its stone base. And when we select any of these chamber products, HydroCAD can automatically use typical spacing and layout parameters for that product. So what we have here is we're seeing a recommended minimum stone base of 6 inches. That's this base underneath here. Then this is our top view or plan view, so we're looking at the top of one block. Now naturally you would rarely use a single block, particularly with a Pavedrain installation. So what we can do is we can specify the number of blocks long we have in a row, and then the number of rows of blocks that we want to use in that installation. So as we increase those dimensions, the complete pave drain system is laid out for us here. And what we can see in the illustration is that we can see the staggered nature of the block that allows them to interlock. And the report here on the right-hand side shows us the overall analysis of that system. So in this case, for example, it gives us a total or a size here for the block, that each block is 12 inches wide. There's 1 inch of nesting between the blocks, so we actually have an 11-inch center-to-center row spacing. So from one row over to the next is 11 inches. And then we get an analysis of the system size. So we have 5 chambers in each row, a foot long, which is 5 feet row length, and then we have this half-foot offset at the end. So that gets added, giving us an overall base length of 5.5 feet for this particular system. And then we have the width, where we have 5 rows, 12 inches wide, with the nesting, and we have 4 of those, which gives us, that is, the nesting is adjusted 4 times, so that gives us a base width of 4 foot 9 inches, in this case. So that is the overall width of the system. Then we get the stone base on which everything is being installed, the 6-inch base, plus the height of the chamber system for a total field height of 0.97 feet, essentially 1 foot high. And then the storage calculation is shown, the total number of chambers and the storage per chamber, giving us a total of 2.4 cubic feet stored in the chamber. So this is the storage in the arch and in the gaps between the blocks. Both of those are allowed for. And then next we have the displacement of the chambers. So here we are typically dealing with an underground storage chamber, so we're displacing the amount of stone that the chamber will take. But here we're talking about this volume occupied by the blocks. The blocks are just sitting on top of the stone, so displacement term is a little bit misleading, but that's how we're calculating it. So we're displacing 10.7 feet of the stone in this entire system with the block that's being installed. And then from all of this we can calculate total storage. So we can take the size of the field, subtract out the displaced volume of the chambers. That gives us the volume of stone that we're using. We then take the voids within the stone, and you can change the voids. There's a default of 40%, but you should certainly verify that and use a void setting that's appropriate for your particular backfill material or base material. So at 40% voids, we calculate 5.6 cubic feet of stone storage in the system. Then we have the storage within the chambers, which gets added into that. And when we combine the two, so we have 2.4 feet in the chambers and 5.6 in the stone, gives us a total of 8 cubic feet of storage in the overall system. Of course, this is an impossibly small system, but just to give you an idea of how the calculations are being done. And then we also get a calculation of the overall storage efficiency. So this 32%, this is the percentage of the total installation of block plus stone, the percentage of that which is open space available for storage. So in a typical installation, these numbers are going to be considerably higher. So we're going to come up to a larger system here, and in this case we're 13.5 feet wide and 10 feet long. So your typical parking lot is obviously going to get a lot bigger than this. We can just go as high as we need to go. So we can adjust the number of rows and blocks per row in order to get the overall dimensions that we want for the system. We can also adjust that in order to get a certain amount of target storage. So if we're after storage as opposed to specific dimensions, we can fine-tune the system until we get the parameters just the way we want them. So it is, like most of HydroCAD, it's a modeling system. What we're doing is we're giving it a proposed design, and it's analyzing that design and telling it how it will behave. If we want a different amount of storage, then rather than entering that target storage directly, we would adjust the parameters for the system until we get the storage that's desired. So that's the basic setup here for entering the paved drain blocks. We've still got typical spacing set over here, although we could change that. We could uncheck the typical spacing, and we might want to increase the amount of stone base. So for a given design, we might put 1 foot of stone under there rather than the default of 6 inches. So you're free to change those parameters as a designer. Naturally, you would not be using stone cover on top of a Pavedrain block, so that would be set to 0, and presumably your side stone and end stone would remain at 0. Those parameters are critical when you're laying out an underground arch or pipe product, but in the case of the Pavedrain, the 0 parameters would be used there. You can also set the invert elevation for the overall system. So this is just the elevation for the very bottom of the stone bed. It's not essential that you set that, but if you were going to route flows through this and want to set up outlet devices, perhaps a culvert that handles the excess flow and dewaters the stone bed, then it becomes important to set the actual invert elevation for the stone bed so that we can set that pipe accordingly at whatever design elevation we choose. We can also use the Chamber Wizard for estimating costs for a system. So we could provide your approximate delivered cost for the block product. We could put in excavation costs and stone costs, and then that would give us an analysis of that system and show us approximately what it would cost. We can also put in an estimated bill of materials here for filter fabric or other items that we might want to include. And this way the price estimate is actually part of that HydroCAD project file that you would send to someone else. So it's a very easy way to communicate not only the Pavedrain layout but also the cost estimate, and to compare different storage alternatives, and that's very powerful. You can actually set up a pond for each of the different storage alternatives that you might want to propose, each with its cost numbers embedded within it. So it's very efficient to be able to compare different scenarios. Now, once we have the basic system set up the way we want it to, we just click the OK button down here in the lower left. And the Chamber Wizard automatically creates 2 chamber definitions for us in HydroCAD. We have one definition, which is the actual Pavedrain block. And the key to reading the storage table is that it's indicating that the Pavedrain block is embedded inside another volume. And this number 1 refers to this first line here, number 1. So this is telling us that we have Pavedrain blocks with their associated storage, but we're embedding those within this overall field, which is what is normally backfilled, or in this case, the base level is the stone product with the 40% voids. So HydroCAD does that displacement calculation and subtracts out the displaced volume of the pavers from the overall stone. Now when we click OK on this overall pond description, we now have enough information that we can start to do some calculations with this pond. So if we double click the pond to open up a report window, we have no inflow at the moment. You'll notice we've just got an isolated pond sitting here, and that's just fine, but it means the Hydrograph, which is the default report here, is empty. But we can look at the Wizard tab, and if I expand this window a little bit, here's the report from the Chamber Wizard, essentially the same information we were just looking at as we designed the system. We can also come over to the Summary tab, and here we have another view. The Summary tab is designed to show us all of the storage definitions that are within a given pond, plus the outlet devices and an analysis of the inflow and outflow. In this case, most of this report is empty, and we basically just have the storage information for this pond. Again, we have here the Pavedrain blocks embedded within this overall field, and this report gives us an analysis of that storage calculation. Now you'll notice here our default storage is in acre feet, and with products like this we probably want to switch this to cubic feet for reporting, so we can just go to the storage tab and we can uncheck this box for large units. So this means that we'll switch to using either cubic feet or cubic meters, depending on whether we were using U.S. customary units or metric SI. So when we click OK, now this report is updated, and we're now seeing the available storage in cubic feet, which is more convenient for us. The next report we want to look at is the Storage tab up top. Although this report is showing us the total storage for the system, when we're doing hydrograph routing within the model, we need to know the precise stage storage characteristics of whatever our storage products may be. And that shows up on the Storage tab. we can toggle this back and forth between a 2D and a 3D view. If we switch this to a 2D view, it's a little bit easier to see just what's going on here. What we have is on the left side of this curve, we have the elevation, and we're starting at 100 feet, which was the invert elevation I set for the base of the product. And then we're coming up here to approximately 100.5 in this situation. You may recall that I'd increased the amount of stone from the default of 6 inches up to 12. So in this area here, we have stone. And you'll notice that we have this linear increase in storage that's occurring because of the 40% voids in the stone. Then here we have labeled the invert elevation for the block. This is the bottom of the block. And at this point, if you look closely, there's a slight point of inflection. And what's happening there, and I can actually zoom in to show that a little bit better. What's happening is that we have just stone to that point, and then we have additional storage within the arch and under the block and the gaps between the blocks. Then when we get to the top of the arch, we have another point of inflection because now we only have additional storage within the gaps between the blocks. The arch is fully submerged. We have no additional stone storage, so there's just a slight additional increase due to the gap storage. So this is the overall stage storage relationship for that block product. And this is what we would need if we wanted to do a detailed hydrograph routing through the model. So that's the rough outline of the minimum involvement that you might have with HydroCAD with Pavedrain. If your goal is essentially just to lay out a Pavedrain system, then you would just come into the Chamber Wizard, set your system dimensions, do an overall layout and an analysis. And you might stop just there. You might then send this project on to someone else who was doing a detailed hydrograph routing analysis, or you might be doing that yourself in either case. And what I should have done here, a couple of things. We should have labeled the nodes as we went along just to make this report a little bit easier to read. But if we were modeling an inflow, a runoff hydrograph, then we would just drag a subcatchment into this model. We would take the outflow handle from the subcatchment and drag it over to the pond. And then we could edit our subcatchment, and we could put in appropriate information. This starts by entering the area and the curve numbers. So this could be the surface of the Pavedrain installation itself, but we might also have adjacent contributing impervious areas such as roof or other conventional paving surfaces. We might also have grass, lawn, whatever other surfaces are involved. And these might be modeled not just with one subcatchment, but we might have multiple subcatchments, all of which are coming into this same storage system. So this might be just the surface of the Pavedrain, or it might be a larger contributing area. So if, for example, this was just the surface of this Pavedrain installation, just refreshing my memory here, this Pavedrain installation we've got here, I just want to come over and look at our field size. So we're approximately 18 feet wide. We're about, let's say, 18 feet square. So this is really very small, but it could still be modeled by coming to our subcatchment, and on the area tab, we deselect large areas. And so our 18 by 18, let's just call this 400 square feet. And the curve number is normally used to define runoff. And although this is a pervious product, we're not actually getting runoff in most cases. We want to capture the entire amount of the rainfall and run it down through the block. So we would typically still use a high curve number for complete capture of that rainfall. We can enter those values directly, or we can double-click in order to go to a lookup table where we can choose the appropriate value directly from that table, and that provides a curve number for us. We would also usually provide a time of concentration for the time it takes water to flow from the subcatchment to this point of collection. Now in this instance, as soon as the rain falls, it's basically there. So we have essentially a 0 TC, and that's fine. We can just leave the TC table blank. So basically just put in the area here, and we need to provide a certain amount of rainfall falling on the system. So if we go to our calculation settings, we could specify a rainfall depth of, let's say, 3 inches in this case. There are a lot of other rainfall settings we can define, including a complete list of rainfall events, but in this instance I'm going to skip those steps and just put in a specific depth. So with that information, if we now double-click the subcatchment, we get a runoff hydrograph, or in this case, the rainfall falling directly on the surface of these blocks. With a very low flow rate, you notice just 0.045 CFS, and yes, we can adjust the decimal places or units there in order to give us more precision with these very small systems. We can now look at what's happening in the Pavedrain installation just by double-clicking that node. And what happens there is we see the inflow hydrograph coming into the Pavedrain system. And what's more interesting, we have no outlet devices here. We're basically just retaining the entire volume. If we right-click this and go to Report Items and select Elevation, it shows an elevation curve. And this is basically the water level filling in the Pavedrain system. So we're starting down here at an invert of 100 feet, which is the bottom of the stone bed that we've defined, and then the water level is filling up to 100.65 during the storm. Now, if this system were to overflow, then we might have a weir as an outlet device that might simulate that overflow. We might have a culvert outlet, a perforated pipe buried in the stone, whatever is appropriate in terms of an outlet device in your particular situation. But here we're just retaining the entire volume. We can also have other contributing areas coming into this. So it might be that, again, I should have done a better job in labeling these. So this subcatchment might just be the Pavedrain surface that's coming in. And then we might have another subcatchment which is contributing rooftop that's coming into the model. I haven't put any data in for that yet, but just to give you an idea of how you could set up the model. So you can have multiple contributing runoff areas. Another thing that you would commonly want to do is to model the infiltration or exfiltration from this Pavedrain system into the underlying ground. And to do that, we would just come in and edit the Pavedrain pond, and we would treat exfiltration as an outlet device. So we've been through the Storage tab. We now go to the Outlet tab and double-click there. And there's a lot of different outlet devices available, but in this case we would set up exfiltration and click OK. And there are a number of different options for how we can define our exfiltration. We could just specify a constant flow rate in CFS, but more common is to specify a velocity. This could be determined from a perk rate, for example. It could be the equivalent velocity, perhaps 2 inches per hour will infiltrate into the surrounding ground below the stone bed under the Pavedrain. And we can specify whether this velocity is to be applied over the surface area, horizontal area, or wetted area. Now in this installation where we have quite a shallow bed, those three values are all pretty much the same, so it doesn't make a big difference as to which one you select. But if you were modeling structures such as a dry well or other ponds that have a large vertical surface area, then it would be important as to which of those was selected. So that's typically all we need to provide, and this flow is normally discarded. That is, it's not being routed further downstream in the model. The discharge multiplier we normally leave at the default of 1. And we also have options to define certain impervious areas within a pond. That typically wouldn't apply to a Pavedrain installation, but with different kinds of ponds that would definitely come in. And then we can just click the OK button in order to store our exfiltration outlet, and OK again to store the results and update our report. And now we have a more interesting analysis going on where we have our green inflow hydrograph as we did in the beginning. That has not changed. The gray is our water surface elevation, and then this brown curve is our discarded outflow. So this is actually showing the water flowing out through exfiltration, reaching a maximum level here, and then decreasing as the system empties. And we can see what the maximum water surface elevation is that's achieved in the system. And if we come back to the pond summary, we get a more detailed analysis. So we get the total volume coming in through our system. And again, that's in acre feet. We can switch those numbers throughout the entire project back to cubic feet. Makes it a little easier to work with. So now we get an analysis of the hydrograph routing. We have our storage analysis, and then we have our exfiltration, our outlet, essentially, for this particular device. And coming to the stage discharge curve, we can see the outlet characteristics. But essentially, we have this very rapid increase in exfiltration. So right down at 100, where the bottom is wetted, we jump up to get our total exfiltration. This is the 2 inches per hour multiplied by the bottom area, and then the exfiltration jumps rapidly as we get that level. There'll be a slight additional increase perhaps through the side walls if we had selected the wetted area option. Those are both available. So that's pretty much a complete overview of the things you might do with a paved drain installation. Of course, you could have many other elements in this model. You might have an overflow from the paved drain system as a pipe which is coming down and feeding another larger detention pond. You might have channel routing effects that you want to model. And those can be done by bringing a reach into the model. So there's many, many different capabilities available to you here. And we've got a significant library of other recorded webinar sessions that you can have a look at that deal with each of these topics separately. We spend about an hour on each of these, whether it be rainfall event setup, underground storage modeling, issues of selecting time of concentration and curve numbers. You can have a look at those separate sessions. If there are any questions, please feel free to put them into the chat or the question box, and we'll either deal with those now or a little bit later on. We can certainly get back to you by email if we don't cover any of those during this session. Doug, did you have any other questions at this point? Is there anything else you'd like me to cover?
No, I appreciate you covering this the way you do with professionalism and expertise that you offer and bring to this. We've made presentations that we do around the country. It is kind of shocking how many people raise their hand when we come to anybody use HydroCAD or who uses HydroCAD, and invariably multiple hands go up every time we do it. So very encouraging to know that this software is going to, this program is going to be a big part of what we're doing around the country.
Yeah, that's great. Yeah, actually, we had a question that was posted. Someone asked about relative cost per square foot of paved drain versus traditional underground piping. Now, I'm not sure exactly. Obviously, there could be under drains in the system. But I don't know if you want to comment on that. Someone
Sure.
else asked about cost per cubic foot of storage. I guess they're looking for a rough number.
I will give the cost of the paved drain system around the country generally gets delivered to the job site, and that's assembled into mats, for between $6 and $7 a square foot, just for the standard gray units, matted together, delivered. Installation on top of that runs $1 to $2 a square foot.
Okay.
So there's your larger jobs go down. We've had a large project in Louisville at the Ford Motor Plant that was installed for installed everything around $6-7 a square foot. So that was a significant amount of square footage. So it can drop from there.
Right.
But you want to get more storage, then you look at layers of rock. You cover this, various gaps of rock. Larger diameter stone will change that. And then down in some of our southern states, we're seeing a lot of work with the other chambers. Peter, did you want to run through adding in a chamber or two?
Yeah, absolutely. Yeah, very good point. And before I do that, just to reinforce, the paved drain system itself is obviously able to handle the entire volume of a storm. That's the beauty of it, that you could take probably your 100-inch rainfall event of 4, 5, 6 inches, and you could retain that entire volume in your stone.
And it would infiltrate. In seconds too.
Right.
We just did a ASTM pervious test into the system, and as hard as this may be to believe, they were looking for a minimum of 8 inches per hour rain event, and the calculations that were brought up was paved drain system could handle over 1,000 inches of rain in an hour. That's how fast it infiltrates.
Right, in
And this
terms
is
of a rate. Yeah.
it's just a staggering rate. It's
Right.
but we have video of it. It's on the website. We have documentation of it, so you can see just how much water this system can overtake. And this is on a test that is per SDM standards and has been in the ground for almost a year. So there's been no maintenance been done on it either. So that shows you how much water this will intake. This will literally inhale.
And as you're suggesting, if you want to provide additional storage capability for inflows from other sources, then the first thing you can do is you can simply increase the depth of the stone base, if that's cost effective for you and you have the vertical room to do it. And then you can also stack these systems. So you could essentially take a Pavedrain installation and you could put that on top of some other underground storage scenario. So here we have a Pavedrain system with an invert of 100 feet. If we come to another blank line on the storage tab, double click, let's come back to the Chamber Wizard, and now perhaps we want to do a pipe storage system. So we could take 12-inch corrugated metal pipe and we could build a system of pipe, and presumably you would be matching this to the size of the Pavedrain installation. I've got quite a mismatch in this example. But you can select a given pipe product and again apply typical spacing for that product, and this gives you the bedding that's required and the cover space between the pipes, and it gives you the overall storage. And then we could set this system at the right invert. So in this case we have a system height here of 2 feet exactly. So if we wanted to place this underneath our Pavedrain installation, then we would place this at 98 feet. So the bottom of the stone here is at 98, the top's at 100, which is where the Pavedrain system starts. So we click OK here and OK again, and we've now stacked those two installations. So if we go to our stage storage, then we're going to see here a little bit more complex curve, but what we're looking at is field B is this pipe system. So we have the stone under the pipe, we have the storage here in the pipe plus the surrounding stone cover on the pipe, and then we have the Pavedrain stone and the actual Pavedrain blocks above that. So we have combined the storage of the underground pipe system as well as the stacked Pavedrain installation. And you can do this with any underground storage solution you choose. So you can just come right back here to field B, our chamber system or pipe system in this case, and we could change that, and we could put concrete galleys in there. We could put a prefabricated chamber product in there instead, whatever you want to use underneath. And so that way you've got the benefit of the pervious surface absorbing all of your rainfall directly, plus the ability to augment that and provide essentially whatever amount of storage you choose. And it's very easy to do different scenarios here. You could compare just using stone, if stone is cheap on your particular site, or you could compare it to using a perforated pipe or an arch chamber product embedded in that stone. So lots of different options, whatever you want to use. Some other questions came in here. Someone asked about maintenance costs, and then more specifically, how does it hold up to snow removal blades? What snow zone municipalities have accepted this product? Any municipalities allow this for small public roads or just private lots? Do you want to comment on that?
I can address all those. Let's go. The first one is maintenance. What we've experienced on some of our parking lots, which has been going over 2 years now, is that they have not had to have any maintenance. That has been obviously every site is going to be specific, but the open joint concept and the open joints that we do with Pavedrain, you don't have to, and we don't backfill our joints with another smaller stone chips or sand layer. It helps allow the fines and everything to just work its way right down through those joints and down into the larger stone bedding layer that's below Pavedrain. The smallest stone that we incorporate under Pavedrain is a 3/4 inch clean. The reason we get away with this and can is because the footprint of the block is so much bigger than a traditional little paver. This block has a footprint of about 1 square foot. That means we can get by with bigger rock, which makes things easier on the job site. Now, if you're on a heavy residential area where you may have magnolia trees or a willow tree or something that's just dropping, almost crazy amounts of tree debris and trash onto this, it can plug or clog and not infiltrate as fast. The remedy for it is a street sweeper or conventional road equipment that can, with air compressors, to blow the joints clean and sweep them up. And it's right back, ready to go. And any of those fines, anything gets down into that rock layer. Most of our rock layers are 12 plus inches in depth. So you're talking decades before anything can happen. And let's say something really drastic does happen to pave drain. You have a truck tip over and dumps half of the load of sand on something like that, and you can't sweep it up, and it just doesn't seem to be performing as well. And let's say it's been in for a decade. You could expose the cables and pick a mat back up, clean your aggregate bedding layer, and then put all that material right back in, same rock, cleaned rock, and the same pave drain mats could go right back in, and voila, you got an whole new brand new impervious surface, allowing for infiltration. So there's some highlights on Pavedrain for the maintenance side of stuff. A lot of this is available on our website at pavedrain.com. And then the other question was snow removal. Easily be done with snow removal. Pavedrain blocks are big and thick and bulky, and we do not have to be snowplowed with just a rubber tip blade. We can be snowplowed with a steel tip. I'm in Milwaukee, located and live in Milwaukee, so I'm in a northern climate, and realized that it was going to be a little challenging to make sure that every snowplower in a given area would know where the pave drain mats were, and they had to have a rubber tip on it. Hence the reason we went with a steel blade. Worst thing you're going to happen to a pave drain mat or block is you're going to chip it. You may chip a corner of it with a steel blade. That is, it's nothing. All the corners are chamfered and rounded. There's no edge for a snowplow to catch on, and you can snowplow it with conventional equipment. And then Peter Rose, one of the other questions, I had that, maintenance and snowplowing.
Any municipalities allow this for small public roads or just for private lots?
We are, our partner out in the East Coast, Ernst Mayer in Maryland, is going to be doing a small roadway in Maryland for the county, for one of the counties. I think it's starting to ship in the next week or so. Dan, do you have an update on that? Is Dan Bishop there? He might not, but that's going to happen. So in a nutshell, yes, we are getting started on roads. We've done our own little tests on it with heavy trucks driving 40, 50 mile an hour, slamming on the brakes, turning on it. We're very confident it'll work. Nothing's happened to it. It's, again, if you've seen the block and could just see the size of the blocks, they're big. They're very heavy. So, but it is a flexible, truly flexible paving surface that allows for massive amounts of infiltration, and seems to solve a lot of environmental problems and takes a bunch of problems, combines them into one product.
Would you like to comment at all about how it compares to using a permeable paving surface, an asphalt or a concrete?
Sure. What some of the analysis that we've used is engineers or municipalities will walk up to me and ask all the great questions, as some of we've covered, and then of course it always gets down to, well, what's it cost? And I always like to say that pave drain costs about half of what a traditional asphalt or even concrete parking lot would cost. And of course that's kind of a shocking statement, because they immediately think of just the square foot cost of traditional asphalt and concrete, so they're immediately thinking $2, $3 a square foot. And I always say, no, it's about $10, $11 a square foot installed. And they say, well, how do how do you come up with that as being half the cost of asphalt? And I said, well, asphalt, that product, and concrete just do one thing. They pave over the top of it. You have to account for stormwater because there's no infiltration within those systems. So you have to account for the cost of piping it, buying the land to build a detention pond, excavating out more rock to include underground detention, buying the piping that goes underneath that. All of those things coming into play. And then how about a detention pond's life cycle? Maintenance of that, the aesthetics of it with geese and their droppings and erosion around a pond. And then as a landowner, you got to pay property taxes on that. Well, life cycle of that gets very expensive. Articulating concrete blocks have been around for 40, 50 years. A lot of us don't know, a lot of people don't know where they are because they're vegetated and covered up. Pavedrain is truly flexible, and roadway engineers, they'll during the design process, they'll talk incessantly. We've got to keep the water out, of that base. We can't let the water get into the system. Can't let it get below the roadway. And what I like to say is, so after 200 years, how's that working? It's borderline impossible to keep that water out, so let's quit fighting it. It's unrealistic to think Pavedrain is going to go on mainline highways. It's not. Or every last city street or county road, it's not. But DOTs all over the country where we've traveled have immediately grabbed it and wanted to use it on a shoulder road as a catch basin along the shoulders, and putting it down the middle of city streets. And instead of city streets tipping outwards, they've drained everything to the Pavedrain system, or let it be just almost dead flat, so the water will capture into the Pavedrain system and work its way back down into the ground, back into Mother Nature where it belongs. She is, after all, our best filter. So those are some of the cost benefits that we're seeing and talking about, and we're seeing the engineering community almost readily grab onto the ease of this of infiltration. That's why the buzz is all out there about getting things back into the ground. Piping is expensive. Buying land for a developer is expensive. So those are some of our
Good. That's excellent. That's good background. The Pavedrain definitions are available in HydroCAD 10 starting in Build 3. So if you go to the Help About screen, then you can check your build number. Just make sure you've got Build 3 or later. This is included in our full HydroCAD product and also in the free HydroCAD sampler, which is available for download. And there is also a special Pavedrain edition, which is pending, which will be a special version of HydroCAD that's going to be distributed through Pavedrain, so you can look for that as well. We'll have a recording of this session posted online later today, so that it'll be available to you or to other people. And we certainly have a whole schedule of sessions that have now been scheduled for the spring and summer. So I'd urge you to have a look at those, and welcome you to join us for anything in the future that you might find of interest. So I want to say thank you very much to Doug for joining us today. And if you have any other questions, feel free to contact us at HydroCAD or Doug directly, and we'll be glad to get back to you. Thank you all so much.
Thank you.
Thank you, Doug. Have a great day. Bye-bye.
Bye-bye.